Okay, so I'm starting now. Hello everyone. Welcome to the fourth workshop of Event Cassandra. This workshop is mostly based on the tree based models you will be using in your upcoming data science competition. So let's continue our discussion from the previous workshop. So most of you, I think most of you will know that we have left our discussion on the topic of validation and train test split. So I explained a term there, cross validation, or what is a validation set. So let's further on this discussion. We will understand firstly the two terms which you will mostly be encountering while you will try to fit a model. That is number one, how to check model generalizability. So first of all, what is generalization? So suppose you are training a model on a data set which is normally we called as training data set, and then you fit a model and now you need to test that model. So you not have the access to test data because it will be hidden from you, or maybe you will not touch that test data when you will creating your own project, and in competition it is not available to you. So one questions come, how you will check your is your model generalizable, means it is not overfitting to the training data set, underfitting, or there may be not bias or variance in your model. So for doing this you need to perform cross validation. And another thing is, suppose you are performing cross validation, so how you will tell that on what factor you will ensure that your model is good. Like you are performing cross validation, but for that also you need to have a number, an entity which defines your performance. So for that you need to have the knowledge of matrices basically. So let's go on with cross validation first. Basically, cross validation means it is a way to create a dummy test data. What we mean by dummy test data here is that suppose you have, like you have the access to training data only, and you will not have enough resources to create data by yourself. So how you will test your model? So for that you can do various things like create a development set, which is generally known as validation set as well. So there can be multiple ways of creating that validation set. Now you will check model performance against development set and training set. So, and that model performance can be helpful in hyperparameters. Basically your model, like a machine learning model, has a lot of arguments to pass, like a lot of parameters which you will need to set by yourself before training a model, and based on that settings your result may vary. So you will need to set those hyperparameters, but how you will do that? So this cross validation technique will help you in dealing with hyperparameter selection. Like you will see a plot, there is two lines there in the plot. First is for training set, the error for training set, you can say loss for training set, and second is for validation set. So you will see as the number of iterations goes on, there will be a point before which your both training set and validation set loss is decreasing, and after that point validation set loss increases and training set loss decreases. So after that overfitting situation will occur because your model is not generalizing, it will going to be overfit on the training set. So you need to find that sweet spot, like you need to train the model up to that point where training loss and as well as validation loss will mutually cooperate with each other in terms of error. So this curve also helps you in like selecting various hyperparameters. Based on hyperparameters how this curve behaves, you need to analyze those things. So now comes to the different techniques of cross validation. Basically there are two such techniques which people generally follow in data science community. First is train dev test split or train well test split. What is that? What is it? So you not have the access to test data, so it will black out from our scenario. Now comes the test training data set. Now what you will do is that you will divide your training set into two parts. Suppose you will divide into 80 to 20 ratio, like 0.8 for training and zero point 0.2 for validation, because generally you will not try to give too much data for validation, because you need to train your model as well, because data is valuable, like data is very precious and for training your model as well, so you need to divide. One way is this, but this has a drawback, like it will help you in creating generalized model, but you will lose an amount of data while creating a validation separate validation set. So as a remedy of this, there is another technique known as k-fold cross validation. So I'm sharing a pic, and for classification task, there is another variant of it is which is known as stratified k-fold. So I'm by this picture I will try to summarize what this method all about. What it does is that, suppose in the previous example you have created 80 to 20 ratio set. Here you will divide the entire training set into 5 parts. For each part contain 20% of the data. Now what this algorithm does is that, suppose this is known as k-fold. So suppose this is for 5-fold cross validation. What it does is that in each fold it takes one fold out for validation and the rest for training, and based on that it done 5 iterations and compute the performance of those 5 performance. I will tell you later what it is. So based on these 5 iterations it will compute a performance, and they then take the mean of these 5 performances. So in all you will get the feeling that each iteration will get a flavor of the test which is of the training set which is maybe used in validation test in the previous iteration. So in that fashion you will be able to like utilize all your data set, but it is not a like it is not a go through go to method for your data science like model selection, because you will see that you will be using all your data but not like the same way. Maybe like suppose your data distribution is not balanced, so your one validation set may give very good agreement with your training data set, but suppose one validation set contains many outliers as corresponding to the training data set. So that suppose performance 5 is representing that distribution where your validation is very different from the training one, then maybe your model will not able to deal with that, so your overall result will be affected by it. So it will be highly affected by the distribution of your data as well, like how your data is picked in validation fold. So that's why for classification tasks maybe you have 90 labels of 1 and 10 labels of 0. If you will randomly pick 5 sets from them, so then a situation may occur like in a validation set there is no label of 1, then how you will judge that? So that's why a technique known as stratified key fold is performed, which ensures that in each validation fold a ratio is maintained for each label. So suppose 5 folds, then in each validation fold at least two labels must be there for 0, and apart from that 18 labels must be for 1. So in that way stratify maintain a ratio of labels, and which is very necessary for classification tasks to make the model more robust. Now comes how we will analyze performance. Like you will see in the previous slide that there is a performance term. So one question arises, how we will analyze performance. That comes the metric. Like metrics is a way to tell the performance. Basically we humans not be able to see some loss curve, like we are not familiar with dealing with curves from our birth. We are generally familiar with a number. Like if we able to decode some information in the form of a scalar value, then it is more intuitive to us apart from some curves or some equations. That's why we will try, like the data science community will try to decode our performance in terms of a scalar entity which will be more intuitive to us. That's where come the metrics. So for regression there will be separate metric, and for classification there will be separate. So let's take some examples of regression metric. Number one is mean squared error, which is known as L2 loss as well. L2 loss or L2 metric, it can be used interchangeably. Loss and metric are used interchangeably based on our requirement to optimize. Second one is mean absolute error, that is L1 loss. So you will see these two photos. MSC is like taking the mean squared error, actual value and your output, like your predicted value. We are taking the summation of all the possible output and predicted value in your data set and take the mean of it. This is MSC loss. And second is the mean absolute error, which is taking the absolute instead of taking the square. These two have their own significance. Like you will, if you will try to explore, you can Google them on and read a article on each of them. They have their own consequences, drawbacks, and advantages based on how they modify, like how they optimize the metric, like how they optimize the model. Now comes for classification. So I'm just sharing a picture which summarizes most of the metric used in classification task. That is this type of metric, like this type of box is generally known as confusion metric. Like it confusion, like actually its name is derived because it a lot of confusion is there in the mind when someone reads it. So I will try to explain in simple terms. Basically, suppose there is a classification task, you need to predict a binary number, like you need to predict 0 or 1. So suppose for a label 0, the x-axis side, like the row side represents actual value of it, and the column side represent the predicted by the model value. So suppose if a label is 0 and your model outputted it as 0 as well, then it is referred to as true negative, because 0 is negative and it represented it, like it predicted it correctly, so it is true negative. Similarly, if your model is able to predict 1 and the actual value is also 1, then it will be referred to as true positive. Now suppose your actual label is 0 but your model is predicted 1, then it will be referred to as false positive, because your model is making a false assumption of being positive. And suppose your actual value is 1 but model predict is 0, then we refer to it as FN, false negative, like your model created false assumption of being negative, like the label is negative. So based on this confusion metric, there can be, based on this confusion table, there can be different types of metric possible. Number one is accuracy. Like we all understand by the term accuracy, most of us, like accuracy is somewhat like a number divided by the total number is we refer to as accuracy for some suppose, but accuracy is not give an exact answer for most of the cases. Suppose there is equal distribution of labels, 50 label of 1 and 50 labels of 0. Then suppose your model outputted 100 zeros. So your accuracy will be around 0.5. In that case, accuracy is good metric. But suppose your model is treating a data set which is very biased towards one label, like for cancer detection. Cancer is very rare disease. So you will get a one label, very one label 1 is very rare in that data set. So suppose your distribution is like 99% of zeros and 1% of ones. Then in that case, if your model is able to predict all zeros, then your accuracy is 99%. But your model is not good, it is worse. You will be able to understand by yourself. Like, then in that case, a new metric known as F1 score will be like used. F1 score. F1 score take into account recall and precision. And now recall is basically mean by, you will see the formula true positive by true positive plus false negative. Basically, recall means that out of all the labels, out of all the true values, how much you have predicted true, like how much the model has predicted true. Yeah, how much the model has predicted that label correctly. This is mean by recall. Now there is another metric which is known as precision. Like out of all the labels, out of all the true labels predicted by model, how much is actually true? This is known as precision. You will understand by the term precision, precise. How is the model precise in terms of the actual value of that label? And recall is that how much is your model is able to memorize out of all the models, like out of all the labels. So that's why I am also confused telling you in this, but I am in my mind I am very clear what these terms mean. So you need to go through these terms by yourself as well to get a clarity, because I am explaining you these terms will make you feel more confused. But all in all, F1 score is a metric which is generally used in classification, which is known as the harmonic mean of recall and precision. It will equally balance one label over the other, and it will be generally used in those data sets which have a very biased distribution towards one label. So that's all. Before dealing with models, you need to like understand these terms very well, because it will help you in selecting a model for your dataset. So now Ujjwal will take over from here and explain you some tree based models. So Ujjwal, will you take control or I will stop sharing? Okay, ठीक है, 1 minute. स्पीक अप करके बोल दिया करो यार, मतलब how stratified k fold maintains levels in different folds. Can you like elaborate your question a bit?
But yeah, I didn't understand stratified key fold.
Okay. What it mean by that? Suppose you have 100 rows in your dataset and you are performing 5-fold. Then what it does is that it divides your dataset into 5 equal parts. So in each, like each fold is represented by 20 arrows. Then in training set, 80 arrows will be used, and in validation remaining 20 will be used. Then in another iteration, those 20 which will be used previously in validation now will be a part of training, and then from training, from 80 rows of training, any 20 rows will be taken out. So in all the, like after completing 5 iteration, it will be ensured that almost all row will be used only once in validation data. In that way it able to maintain the 5 folds in validation data. So
Yeah.
mhm,
And what was the F1 is and score there?
mhm.
The right hand side, we understand that the equations were given, but what was the F1 and score there?
Ujjwal, please share that screen now. So F on what part? Like just a slide before. Yeah, this F1 score.
Yes,
Basically,
yes.
F1 score is referred to as a metric which tries to balance this recall and precision, like how your model able to memorize this thing and how your model is able to precisely
Okay,
tell
okay.
what it is.
Means
So
the
suppose
F1 score is there, not that is not the minus sign, right?
F1 score, yeah, it is not minus sign, it is F1 score,
Okay,
like
okay.
a way of representing it. Okay. So any other questions before Ujjwal
So
will
how
start?
stratified is different from normal key fold? Both side.
Stratified is that like suppose normal k-fold, there is no insurity that your validation fold, like your validation part, contains equal distribution of labels as in the original training set. Suppose your original training set will have a label distribution of 80 is to 20, but maybe after k fold, the validation fold is the resulted validation fold may not have any label of, like may not have any data of one label. Maybe all the data of that label will be gone in the training set. So how your model will be able to evaluate like on that particular label? So in that way, what it does is that it able, like it computes the ratio of your labels like in the original training data set, and then divide the folds in such a way that the ratio is maintained in each fold for that label. So suppose each fold will have a ratio of 80 is to 20 for each label. So in that way, 4 folds is used in training, which have the ratio same as 80 is to 20 as of validation fold. So in Is the doubt clear?
Yes, Bhaiya.
Okay, so any other doubts, or Ujjwal will proceed? Okay, okay, Ujjwal, you can take on from now.
Okay, now let us begin with what is decision tree. So basically, it is basically let us just analyze the diagram, what it is telling. So basically, what is the outlook? It is saying that the first node, what it is outlook, whether it is sunny, overcast, or rainy. So let us say it is sunny. So we go here, and here there is present humidity, and there are two options, whether it is less than 75 or greater than 75. And in a similar way, here it is overcast, like cloudy weather, or here it is rain. And so after rain, there is also one option, windy, whether there is wind or there is no wind. So what it tells, basically, let us say you want to go out or not, so you will basically fall down the tree. Like let us say the weather is cloudy, so you will definitely go yes. Like if any person is there, so will say yes, you should go out. And let us say if the weather is sunny and the humidity is also greater than 75, then probably we will say no, that you should not go out. Or if there is rain and there is high wind, then also we can, if there is high wind, then also we can say that you should not go out. So basically, decision tree gives you some particular decision, like it helps you to take some decisions based on its algorithm. So let us see how it does that. So basically, a decision tree is basically one of the most popular machine learning algorithms. It uses a basically a tree-like structure. It is a tree-like structure, and its possible combination. It tries to generate all the possible combinations and take the optimal one out of it. Also, it belongs to a class of supervised learning, like you are giving the labels also and the features, the different inputs also. So it belongs to the class of supervised learning, where it can be used for both classification and regression, and also it can be both used for classification as well as regression. I will tell you afterwards that how it can be used for regression as well. Now decision trees play an important role for prediction, like they are basically telling you whether you have to go out or not, like that. And also nowadays decision trees are named by CART, like which stands for classification and regression trees. This is because it is able to do both the task. Like it can also classify the objects, and also it can perform regressions better than some well-known algorithms like linear regression. It can perform the task more complex in a more complex way. So this is all about decision tree. Now let us say what are the terminologies, like what are the different parts. So first one is root node. Root node basically contains all the data set, like under it falls everything. So this is basically the root node, and it further gets divided into decision nodes. Like this is a decision node, which is basically the mid-level nodes. Like they further divided into different kinds of nodes. Like here is it is a terminal node, and here it is the decision node. So what is a terminal node? Terminal node basically, as it means, afterwards there is no node. So it is the end of all the nodes. And basically here lies the answers. As you have seen here also, the answer was at the terminal node, like yes or no. So that is basically the terminal node, and these all are decision nodes. And this is basically called as a subtree or branch, a part of a tree. And what is this? This is basically splitting. So now let us stand in more deep, like root node. Basically, it represents the entire population, and decision node is basically a middle level node. When a subnode splits into further nodes, it is called as decision node. And what is leaf node? Nodes that do not split are called as leaf nodes. So these are very easy terms. Now let us understand what is splitting versus pruning. So splitting is basically dividing a node into two or more subnodes. This is easy. But when it comes to pruning, let us see what it is. So pruning, when we remove the subnodes of a decision node, like let us say we have divided a node into two nodes, and we see that there is no benefit from it. Like it results in overfitting or something else. Like we are not getting a better result. So basically we remove both the nodes, and we do not split. So this process is called as pruning. It is basically the opposite of splitting. It is just the opposite of splitting. So this is called as pruning. So I hope you are clear up till now. Now let us say what is the algorithm intuition, like how decision tree works. So basically, what we do is first we choose which node to be chosen as root node, like what feature should be at the top. So one of the most important thing is to choose the feature which should stay at the top. So that is chosen using an algorithm which I'll teach you later. So now let us say we have chosen a root node. Then what we do? We do the same thing for other nodes. Let us say we chose the branch root node, and then we created two more nodes out of it. So how we create the two new nodes? Two nodes are created in a similar fashion, like we created the our root node, and this process continues until a leaf node is reached. Like when we reach a leaf node, then we do not divide it further. And how do we know that we have reached the leaf node? So basically we either give them a parameter like up to 2 levels of depth you have to go down, and afterwards there should be no splitting, or also there can be no increase in the performance, so we can stop splitting. So these are the ways in which we reach the leaf node. And basically it contains what the prediction of the outcome, like it contains whether yes or no or anything else. Like if it is a regression tree, it will contain some value. So this is basically the algorithm. Like firstly we will choose the feature which is most important, and we will place it at the top, and then in a similar way we will build the whole tree, like which is the second most important feature will become the second level nodes, and which is the third most important feature will become the third level nodes, and so on. In this way we build the maximum possible optimal tree. In this way basically we build the most optimal tree. So this is basically the algorithm intuition. Now let us say yes. So how we will select the attribute? Like the basic thing is attribute selection, like which attribute should be at the top. So there are basically two processes known as information gain and Gini index, and these two are very important. So basically information gain is basically used when the attributes are categorical, and Gini index mostly are used when the features are continuous. Like Gini index is used mostly for regression trees, and information gain is used when the features are categorical, like you have to classify whether there is yes or no. So then information gain can be used. So firstly let us know what is information gain and what is also entropy. Entropy is basic. What is entropy? Like entropy is basically the disorder. So less is the entropy, more less is the entropy, less is the disorder. So basically entropy measures the impurity in the given data set. In physics or mathematics, entropy is referred to as randomness or uncertainty. Like if let us say you have a data set and there are 50% yes and 50% no, so that is a very random data set, because you cannot tell what will be the next data, what will be the next answer. Like if I give you next data next thing, and you cannot, because the probability is 1 by 2 for each of them, so you cannot tell. But let us say if there is 99 yes and 1 no, so you can tell that most probably the next one will also be a yes. So there is less entropy, while in 50-50% there is much more entropy. So this is entropy, like how disordered the data is. And what is information gain? So basically by the definition we can see information gain is decrease in entropy. Information gain computes the difference between entropy before the split and average entropy after the split of the data set based on given attribute values. Like let us say you have a root node and you divide it into two nodes. So if your entropy is getting decreased, then you will then there is some information gain. But if the entropy is not getting decreased, like let us say it is increasing or it remains the same, so there is no information gain. So what you will do, you will not try to divide the node. So this is basically information gain. So if anybody up to okay, let me just cover one more topic. So how entropy is calculated? So entropy is basically the summation of I from 1 to c. C is basically the number of classes. Like if you have only two classes, yes or no, so there are two classes, c equals to 2. And if there are more than two classes, there may be c, maybe 3, 4, and so on. So it is minus of pi into log base to pi. So it is basically pi into log base to 1 by pi. Log base to 1 by pi is basically the surprise factor. You can see like if pi is like, let us say if it is half, then log base to 1 by pi is what? It is 1. So there is no surprise. Means there is a high surprise. If log 2 base like if pi is half, then log 2 base half is 1 by half. Like log 2 base 2 and pi is also 2, so the factor is 1. So it is high surprise, like we cannot tell whether the next one will be yes or no. While if let us say everything is yes only, then the surprise factor is 0. So this is entropy, like it gives you whether there is a high surprise factor or no very low surprise factor. And in a similar way, Gini index is also calculated, but it is more easy to calculate. Like it is 1 minus. Okay, wait. Yeah. So Gini impurity is basically 1 minus summation of 1 to c pi whole square. So basically, if let us say you have 1 by half is 50% is yes and 50% is no. So pi is half for both. So 1 by 4 plus 1 by 4 is half, and 1 minus half is half. So it is very high. But let us say only you have all yes. So the pi is 1. So 1 minus 1 is 0. So the data set is called as pure. As you can see, a node is called pure if gain is 0. When all is yes, then it basically becomes 0. And if all the training instances, it applies to belong to same class. Like if they belong to same class, the gain impurity is 0. So this is all about gain index, like how it works. If I have gone too fast. So if anybody has any doubt up till now, you can ask. Let me see the chats. So if anybody having any doubt, you can ask. Like if you have not understand any other things. Okay, if you don't have any doubt, so I'll move forward. Right. Okay. So yeah, there is car training algorithm. So this is a very long thing. Like you should not afraid of it. Like basically how we calculate the net Gini impurity. It is telling that like basically it is the weighted average of the left and right subnode. Like you take the total samples in the left subnode upon the total number of samples in the left plus the right subnode into Gini impurity of left subnode plus the number of samples in the right subnode upon the total number of samples into the Gini impurity of right subnode. So basically gives the net Gini impurity. So by this you decide whether you have to make the split or not. So as you can see also here, G left right measures the impurity of left right subset, and M left right is the number of instances in the left right subset. So yes. So basically it tells like once it is successfully split the training set into two, it splits the subsets using the same logic and so on. Malab, it does recursively, and it stops once it reaches the hyperparameter. Like we set the hyperparameters like maximum depth, min sample split, and so on. Like if the number of samples in a leaf are less than a particular value, then we stop splitting. Or if the weight, like if we can say like we have reached a particular depth, then also we can stop splitting. So these are the different hyperparameters which you can set by yourself, so that that tree does not overfit the data set. Like if you will not just apply these hyperparameters, it will basically overfit the data set that you do not want. So you will basically apply different hyperparameter settings. Now what to use? So most of the time it does not makes a big difference. Like you can use both Gini versus entropy, you can use both, but Gini impurity is faster to calculate because there is no log factor in it, so you can use by default. Also the graph of entropy goes like this. Like the maximum value comes at when the both the data sets are 50-50%, the maximum value of entropy is 1. While in case of Gini impurity, when both the data set contain 50-50%, the maximum value comes at 0.5. So this is the graph. If someone asks, you can tell them also that the graph goes this way. And in a similar way, like I was telling about the regression trees, later on I will also show you a demo. But now you can just understand the logic. Like it behaves the same way. Like it calculates the mean squared error, like weighted average, sorry, not mean squared error, weighted average. Like M left upon total number of samples into mean squared error of left subnode upon right subsamples upon total number of samples into mean squared error of right subnode. So this is basically the weighted average of mean squared error. Now what is the why we cannot use linear models? So linear models can be used, but if there is a high non-linearity and complex relationship between the dependent and independent variables. So a tree model will outperform a classical regression model. So this is one of the most benefit of using a tree model, because in linear, it cannot just analyze all the different features and give you a better model. But in case of tree, it considers various features, and then it will finally give you a better model as compared to simple linear regression models. Also, it is very easy to explain. You can use a decision tree and tell to anyone like how the tree is performing. Like from the nodes, you can go on left and right and so on. So in this way, you can also explain it easily. So regression trees are better in this way. Now, what is the main disadvantages in case of decision tree? So overfitting is one of the most disadvantage of decision tree, because if you do not set the hyperparameters right, then they will what it will do, it will basically make the decision tree up to the whole depth, and it will overfit your data. Like it will give your best answer on your training data set, but if you bring some new data test data set, then it will not perform very good. So this is basically known as overfitting. So what can be used? So there are basically two methods. These are pre-pruning and post-pruning. I have told you pruning. I have already told you pruning. But what is pre-pruning? That you just set an hyperpanel. Like you will not divide if the, let us say if maximum depth is 2. So you will not divide the nodes further. So it is called as pre-pruning. You are pre-pruning them. While what is post pruning? Post pruning is like you have just divided the nodes, but when you perform it on test data, you do not get the good result. So what you do, you basically post prune it. You basically move backwards, and you do not divide the nodes. So this is known as post pruning. So these two methods you can use, and these will help in reducing overfitting problem. Now, let us say what are the parameters like we use in decision tree. So first one is basically the criteria. As I have told you, there are two criteria like Gini impurity or entropy. Both of them you can use, but Gini impurity is better because it computation is less, and it is also a nice one by default. So you can use Gini impurity. And splitter. Splitter is basically the different kinds of split you can use. There are like best splits or random splits, which basically have their own parameters. So you can use splitter also. Max depth is, I have already told you, like up to which depth you want to make the tree. Like if you want to stop the tree up to depth 2, then you can stop it. So this is basically the maximum depth. And min sample slit. Min samples is basically, if let us say if a leaf contain less than a particular samples, let us say it contains only 6 samples, and you want to further divide it, then what it will lead? It will lead to overfitting, because you are just dividing every node. So this is basically overfitting. You are just fitting the training data, but you will not perform on the test data. So we basically tell them a minimum sample split. Like if number of samples in a leaf are greater than a particular value, let us say greater than 6 or 7, yeah, greater than 10, 20, then only we will split the leaves. So this is basically the min sample split. Min samples leaf. So the minimum number of samples required to be at leaf node, like how many samples are required. If number of samples coming in that leaf is less than that particular number of samples, then you will not make that leaf. So this is basically, these two are like almost same. So this is min samples leaves. Now max leaf node, you can also decide the number of leaf nodes in a tree. Like if you tell the algorithm like only 5 leaf node you want, so it will give you only 5 leaf nodes. So this all will help you in reducing the overfitting problem, because as many as leaf nodes you will create, it will lead to a overfitting problem. So these all you can set by yourselves. And also it is min impurity decrease. Like if there is if the impurity of a node is less than a particular value, like if it is 0 or something, then you will not obviously then you will not split it. But it is above than a particular value, let us say 0.5 or 0.3, then you will split it. So this is min impurity decrease. And min impurity split is almost the same. In the same way you can also do this. So what are the advantages and disadvantages? So advantages is that you can easily explore it, useful in data exploration. Also data cleaning is required very less. You can perform just simple data cleaning processes. Data type is also not a constraint. It can perform both on numerical and categorical data, and it is easy to understand. So these are the advantages. What are the disadvantages? Already told you, like overfitting is one of the disadvantages. Also, it cannot guarantee you to return the most optimal tree. Like it cannot guarantee that. So these are the disadvantages. So this is all about like decision tree. So if you have any doubts, you can ask uh, related
Can you
to
explain the pre-pruning and post-pruning again?
yes. So let us say pre-pruning is what? Let us say uh, only this is like let us say I have just given it a parameter max depth equals to 2. Like you are restricting it to restricting it from further division. Like I have set max depth equals to 2, and let us say I have also set one parameter mean impurity decrease, and I have set it to zero point 0.3. So if the impurity of a node is like let us say 0.2, then I will not split it because I have set this thing. So basically pre-pruning is what you are setting some parameters like if those parameters are satisfied, then you will not divide the nodes. In This is called as pre-pruning, because if you will divide it more and more, it will lead to overfitting. So this is called as pre-pruning. And post-pruning, as I have told you, like let us say you do not want to do it, like you do not want to apply hyperparameters at the first step. So what you will do, you will just blindly go for the training data set. You will train that set, but also you will now use the cross validation. Now you will use a cross validation, and you by cross validating you get that your model is not performing very well on the cross validation data set. So what you will do pruning, but you will do it afterwards. Like you will not do from before, you will go do it afterwards. So it is called as post pruning. After you have checked that it is not performing well on your test data set, then you are doing pruning. So this is called as post. And before checking you are doing, that is called as pre pruning. So have you understood?
Yes, understood.
Okay. Any other thing if you are not understood? Like these were a lot of topics. So like Guinea impurity and entropy, you can ask. Or
So what was that data lift and data right?
okay, wait. This one here.
Yes.
Yeah. So let us say you have a root node, and it has two child, left and right. Okay. So G left is basically the Guinea impurity of left child, and G right is basically the Guinea impurity of right child. And m left is the number of samples in the left child, and m right is the number of samples in the right child. And this m is the total number of samples, m left plus m right. And this is what basically it is the weighted average. Because the number of samples may not be equal in the left and right child, so we use weighted average for calculation of overall Guinea impurity. So is it okay?
Yes.
Okay. And okay,
Yeah,
so
what does it doesn't give globally optimum tree mean?
yeah, means many a times you will not get the right parameters. That only means by it. Like many a times you will not be able to get or set the best parameter. So in this, so there may be some other tree which may give some better results. So that is something that it does not always gives you a globally optimal decision tree. Like there are a lot of decision trees possible. Like if you change the feature of root node, like let us say you have like okay, I have just let us say yeah, here I have taken outlook first, but let us say I have taken humidity first, then I have taken outlook. So the result would change. So in this way there may be lot of possible decision tree. I would have taken windy at first, so then also the algorithm would have changed, the result would have changed. So in this way there may be lot of decision tree possible, and it is not always possible that you get the best decision tree. So this is means by that you always do not get the optimal best tree. Okay.
Okay, Vio.
Okay. Also, if you have any doubt about regression trees, like I will also tell you with some practical like diagrams also, but if you have any doubt now, you can ask. So if you do not have any doubt, let us move to random forest. Like what is random forest? So it is very easy. If you have understood decision tree, random forest is nothing. Random forest is basically just it combines a lot of decision trees and it tries to get the best output from them. Like let us say this is one decision tree, this is two, this is three, this is four. So what let us say it predicted class C, it B, D and C. So there are two trees which are predicted class C. So what is our answer by majority voting? Our final class will be C. So this is random forest classifier. It basically classifies a lot of decision trees. And basically here you can see N1 features, N2 features, N3 features and N4 features. So what do you mean by that? It basically means it does not takes all the features at once. It basically takes a subset of features to create randomness. Like if it will take all the features, then there will be no use to create such many trees. So it basically takes only a particular subset of features, N1 features and similar way N2 features and so on. And it takes some only a subset of data set and it creates a random tree from them. And in this way it creates a lot of trees and tries to get the majority voting from it. Like if the majority voting is C, then it will predict the answer as C. So this is random forest classifier. So it is basically a supervised learning algorithm again, and it basically used for regression and classification, and it is one of the most easy to use algorithm. And it creates decision tree on the given data. Samples get prediction from each of the tree and selects the best solution by means of voting. And also it is a pretty good indicator of feature importance. Like it selects some features, so it is also feature engineering also. It is doing feature engineering also for you. So it is selecting some feature, some subsamples from the rows. So these all things it is doing by itself. So this is called as feature selection of feature importance. Now, what is the algorithm intuition? So it is created, random subsets are created from the original data set. Like you basically take some subsets randomly with replacement, and this is called as bootstrapping. Like you are taking some of the data set with replacement. So this is called as bootstrapping. And at each of the node, you only consider a random set of features. You can see here only a random set of features are considered to decide the best split. In decision tree, we were taking all the features together, but here we are taking only a random set of features for the best fit. A decision tree model is fitted on each of the subsets. Like let us say you have created a lot of subsets by using bootstrapping, so it is fitted on all of the subsets, and the final prediction is calculated by averaging the predictions from all the decision trees. Like let us say it is a regression tree, then we will average all the prediction, or it is a classification tree, then we will take the max voting out of it. So this is basically the random forest algorithm, how it does. And what are the advantages? It has a lot of advantages. Like it can be used to solve both classification and regression problem, and it considered very accurate and robust. Yes, because it is combining a lot of decision trees and lot of models are helping you to give you an answer. So it will be better in terms of it will not mostly overfit your data. It will just try to combine all the decision trees. Like and random forest takes the advantages of, like it takes the average of all the predictions. So this is also one of the most important thing. Like it takes the average. Like if some tree are biased towards the data set, then it will cancel that bias. So this is one of the advantage of random forest. And also it can be used for feature selection also. So these are the advantages. And the disadvantages is like it is having very high computational complexity. So this is one of the disadvantage. Like it is very slow in making predictions because there are large number of decision trees. And also the model is difficult to interpret. Like in decision tree you have only one tree, so you can easily interpret, but in random forest you have lot of trees, so it is a difficult task to understand like which trees it is considering for providing you the best possible answer. So these are the disadvantages. Now let me just show you a 2 minute just practical, like how it looked like. So firstly I will just import everything. Like I am importing decision tree and pandas, and I am just reading a data set. So yeah, you can see here it is a data set, and there is sepal length, petal length, and so on. This is a iris data set. You have already seen it. So these have 4 features in it, and there is a class, like which class it belongs to. So I should also, if you want to see the end of the data set, you can use dot tail method. So what I'll do, I will just drop the ID. I have no use of it, and I will create X and Y data set. X is what? These all four features, and Y is what? This species. So I will create this, and I will create a classifier. Tree classifier equals to decision tree classifier maximum depth. I am setting you 2, and there you can give a random state also. I'm giving 36. That you can give anything. So I am fitting it now. Tree classifier dot fit on X and Y. So let us run it. So yeah, you have. Now what is this? This is basically a way to create a graph. This is nothing. This is just a code. You can just copy paste from anywhere. This you need not to learn, but you can just say it from Google itself. So this is the code for decision tree graph. So here the labels are what? The labels are the columns. These are the columns are the labels. Okay. So what I'm doing, I'm creating a graph. And what I'm providing to it, I'm providing a classifier, feature name, labels. I'm providing the number of unique classes. I'm providing the max depth, and I'm telling that you should fill it like uh, color thing, and I'm displaying it. SVG is basically the basically scalable vector graphics and something like that. You can see from the net itself. So it is basically used for graph making. So now I'll explain you the graph. This is important thing, like this is most important. So let us say petal length is less than 2.5. So if it is true, we will go the left side, and we can see the value is 5000. So only iris setoso class is present here. Other two classes are 00. So what is the Guinea impurity here? Here it is 0 because only one class is present. And if it is greater, like if it is greater than 2.45, so we go on here, and here two classes are present 50-50. What is the Guinea impurity? Guinea impurity is 0.5. You can see here Guinea impurity is 0.5 and here is 0.0, because here there is a pure classification. Here all the classes belong to iris setosa, while there are two classes 50-50. So the Guinea impurity is 0.5. And here also we go here and here. So if it is less than 1.75, we go left side. So we can see here we get a better decision, like 49 are iris vesicular and 5 are only virginica, while if we go here 45 are iris virginica and only one is iris vesicular. So you can see this is the optimal tree we can get from it. Like it is doing a great job. And Guinea impurity is also being reduced. Like here it was 0.5, here it is 0.16, and here it is 0.043, and here it is 0 itself. So this performs a very good class, like good algorithm. Let us want to predict on the features 1, 1, 5 and 1.5. Let us say what it gives. Like it gives the probability 0.92 is highest. Like it is giving iris virginica, and you can say like iris. It is giving, sorry, iris versicolor. Like it is giving this one. So let us say what are the features we provided. We provided 5. So we provided what? We provided okay. We provided 5. So 5 is what? 5 is let us see. Yeah, petal length is 5. So we are providing 5. So it is not less than. So we go on here, and afterwards we see if it is greater than or less than. So it is basically it is greater than. So it will basically give you it is greater than, like let us say, yeah, it is 5. uh, Petal length, yeah, it is 5, and petal width is also there. Yeah, petal width is also there. So petal width is less than 1. Yeah, petal width is there. So petal width is less than 1.75 or greater than. It is less than. So it will go on here. So it is basically what? It is a versicolor. So what it is giving is output. It is giving iris versicolor. So this is basically it has predicted it very good. Like it is less than 1.5, and the petal length is greater than 2.45. So both things are satisfied. So we can get iris versicolor. And in a similar way, decision tree also works, like regression decision tree. So I will just show you a data set. Here there are a lot of features and there is a price. So price is basically the y part. So if I say the X data set is, I can take them rooms, bathroom, land size, latitude, longitude, and the Y data set is price. And I want to fit a regression decision tree, and I am providing it max depth equals to 2, and I am fitting it. So let us fit it. Yeah, and I am just creating a graph in a similar way. So what it does, it basically creates a graph. So if room is less than 3.5, so here it is true and here it is false. 3.5 less than means if the room number is 3 or 2 or so on. So it will go here and it will say like this basically gives you the error. This is the error and this is the mean value. This is the value that you will get. If you will go here, this is the value you will get here. In a similar way, it will less than 2.5, it will go on here and this is the value. This is the price. The value is basically the price you are getting. And in a similar way, the whole decision tree is created. Like here it is false, so it will check latitude, it will go here or here. In this way, at every leaf you will get a value. So if you will now just provide a new data set, then you will get, then you will go, then you, it will give you some particular value, like it will give you this or this or this from the 4 leaves. So in this way the regression trees work. So this was all about tree, and I have also attached some references, you can go through them. And in a similar way, random forest also works. So now if you have any doubt regarding to anything, you can ask.
So, Bhaiya, we are using the this decision tree algorithm by by library. So,
Yeah,
can we make our decision tree
yeah,
that can set, yeah, so that we can set maximum depth or
yeah,
the
yeah,
things.
yeah, you can provide all the hyperparameters by yourself only. Means like I have provided, let us say I have provided random state equals to 36. Okay, then it just created a tree using its own algorithm, but you can just provide everything to it, like maximum depth, minimum impurity, split, and so on. So you can basically give your all the hyperparameters and it will perform according to you.
And that where on which point I have to stop and all that.
Yeah, yeah, you can, like I have given it now, maximum depth is 2. So basically it stops at depth 2. It may have created 2 nodes out of it, but it does not create it because the maximum depth has been reached. So like this you can also provide, like I have provided maximum depth equals to 2. Main thing is hyperparameters only, you have to just tune them. That is the main thing in decision tree, and you have to understand like how it is performing. That is also important. So you can basically create graphs like this. So if you have any other doubt, you can ask about random forest or Guinea impurity, anything you can ask, or I will just pass it on to Manak. Okay, so I will stop presenting.
Which one to use out of random forest and neural network?
Yeah, what?
Which one to use out of random forest and neural network?
Yeah, you can means use neural network is also a very good algorithm. So it is also more complex one. So you can use both. It depends on what is being asked. Like I cannot tell you like you should use this or that. It depends on what is being asked. Most of them try to use both. Like in most of the competition, they try to use neural networks also. They use decision tree and tree based algorithms also. So both of them good results. Like that you have to test on the data set. It basically depends on the data set also. So you have to try by it yourself.
Okay, Vijay.
Okay. So Manak, you can now continue.
Hello, so is it visible?
Yes.
Yes.
Yeah. So, when you are, yeah. So when you are training your model, there can be some type of errors. Okay. Uh, the reducible errors are bias and variance, and there may be some irreducible errors which are related to the data set or some inefficiency of algorithms. Okay, so what are bias and variance? So the total prediction error is bias squared plus variance plus irreducible error. So to get the better results, you have
to reduce the total prediction error. Okay, so what is bias and variance? So bias means strong inclination towards something. Means what we mean by bias, to that this person this decision is biased for this team. Okay, so it is strongly inclined to that team. But in data science, when you will hear the terms bias or variance, you will actually hear the terms. The terms are actually meaning bias error and variance error. Okay, so the bias error means that bias error means how much it is biased with the training data, how much the model prediction is biased with the training data. So if the bias is, if the bias error is very high, okay, very high bias error, so it means the model is not well fitted on the training data. Okay, means it is missing some features of the training data. But if the bias error, if it's low, then it means that it is taking all the important features of the training data, and it is well fitted on the training data. So some low bias some low bias models are knn, decision tree, etc. Okay, and high bias models are this linear regression, logistic regression, etc. Okay, and what is variance? So variance means that, let's say you have trained a model on a data set. Okay, and how much and let's say you are again validating it on some other data set, and you are seeing that the performance is very low. Okay, so in this case the variance error is high. Variance generally is indicating that how much your model is generalized over the data sets. Okay, so is if the variance error is low, it means that the model parameter should not change so much for performing uh, on different data sets. Okay, but if the model parameters are changing significantly, if the changes are much more, then in that case you can say that the model is actually biased for I mean, the model is actually well fitted in your previous training data, but it is not performing well on the other data set. Okay, so the high so the low variance model is linear regression, and some high variance model is SVM decision tree. So huh. So here is a plot showing how the what is the bias and variance. Okay, so this is the training data. Okay, and in this case, in the first plot, you can see that the curve, the model prediction is actually missing some good amount of features of the training data. Okay, it is not actually taking into account all the features. Okay, but if let's say you modify this data a little bit, okay, let's say these some data from this part is gone, some data from this part is gone, and some data from this part is gone. Okay, so you have changed the data in you have changed the data a little bit. Okay, but still so in the new data set also, this model will perform in this way. Okay, so in this case, the variance error is low. Okay, because the model parameters are not changing too much when we are checking the performance on different data sets. Okay, but this model predictions are not actually well fitted. This model is not well fitted on this training data. Okay, so in this case, the bias error is high. Okay, and in the second plot you can see that the training data, that the model predictions are well fitted on the training data, but still if you remove some data points, okay, or you shift these points, some in this point a little bit higher and this point a little bit lower, okay, then also it will fit in this way, it will also give good results. Okay, so plot. This plot is actually showing a balance between the variance error and bias error. Okay, it is not actually the bias error is not too much. Okay, and also the variance error is also not too much. Okay, but in the third plot you can see that it is actually overfitting. Okay, and in this case the model is actually taking into account all the important informations of the training data. Okay, so in this case the bias error is very low. Okay, but if you shift these data points up, down, or left, right, okay, then this will predict very this will this model will make wrong prediction on the new data set. Okay, so in that case, so that's why this has a very high variance error. Okay, and so to get the better model, you must have yes, to get the better model, you must have low variance and low bias. Okay, if you have high variance and high bias, then it's inaccurate. But actually, it's actually not possible. Okay, if you try to train your model on each and every important information of the training data, then it will learn the training data more accurately, and it will not be generalized. So if you reduce the bias error, the variance error will automatically increase. And if you try to make the model generalize, if you generalize the model, then obviously it will not have much changes, and it will perform in a moderate way in different data sets. Okay, so in that case, the variance error is very low, but it is missing some good, important information in the previous training data. So in that case, bias error is high. Okay, so this is the error versus model complexity graph. If you have a very complex model, okay, like we have seen decision tree. Okay, uh, so decision tree is a very complex model. Okay, and that's why it is it learns each and every features of the training data, and that's why it has low bias, but it has high variance. If you try to predict it on a different data set, okay, then it will give bad predictions. Okay, so you can never find the most accurate model, because if you have low variance, then you will have high bias, or low bias then high variance. So you have to reach to this point. Okay, this point where both the variance and bias are balanced. Okay, that's why you have to tune the model. There is no model which have low bias and low bias and low variance. Okay, so why teaching this topic? This topic is very important, and this topic is very important because in some data scientist, because in data science companies, okay, like you can say Microsoft Data Science, okay, these companies actually um, rely on these concepts. They rely too much on these concepts. Okay, like you have a data set, and like they can ask you have a data set and you have fitted a decision tree model on that, and the decision tree, when you have changed this label, these you have removed these columns. Okay, and then you are trying to fit your decision tree model on them. Okay, and you are seeing that it is performing bad, it is giving bad predictions. Okay, maybe some features have been multiplied with 10. Okay, so in that case decision tree is giving bad predictions. Okay, so what you will do, why is it happening? So the reason is that because decision tree is a low bias high variance model. Okay, so it is well fitted on the training data. It is performing very well on the training data, but when the training data is modified, then it is not very generalized. It has high variance, and that's why it is not performing well. Okay, so in that case, you must choose some other model. What you can choose? You may have what you can choose. You may have 4 options, and among them you have to find a model which has high variance, which has low variance, but low variance means moderate variance and bias. Okay, so so that's why this concept is very useful, and you will encounter these type of questions uh, in your data science journey. Okay, so the next is your boosting algorithm. Okay, so boosting is a sorry. Okay, so boosting algorithm actually works in a way that it trains multiple weak learners, and finally they combine them to get a strong learner. Okay, so here you can see that this is a linear classifier. Okay, this is a linear classifier. It is only separating the it is only classifying the training data on the base only by a line. Okay, this is a linear classifier, this is another linear classifier, and this is another linear classifier. But when you are combining all this, you are getting this. Okay, so this is a non-linear classifier. It's classifying all the levels well. Okay, so this is the main concept behind boosting algorithms. Okay, now how boosting algorithms work. So first of all, we take a data set and we train a weak learner A on that data set. Maybe you can say linear regression, or maybe you can say logistic regression. Okay, so you have trained logistic regression on it, and then and after that, the labels that are predicted wrong, those weights of these labels have been increased. Okay, because so that again, if they are predicted wrong, then in that case the loss will be much more greater than previous one, because now we have increased the weight. Okay, so here you can see in this image, see this carefully. Okay, here plus plus minus minus. Okay, so here it classified this. Okay, and see these three levels, these are wrong classified. And here in this image, see, the plus has been increased and this minus also has been increased. Okay, so these levels, weights of these level has been increased. Okay, now it has been now again classified trend. Okay, and now the wrong predictions are this minus minus, these 3 negatives. Okay, now here you can see that these 3 negatives, their weights has been increased, but this plus and these minus, their weights have been decreased. Okay, so their weight has been increased because they are wrong classified. Okay, and similar now we have got this. Okay, so to increase the loss, the so there is a weighting function. Okay, and generally all the boosting algorithms, they differ in this weighting algorithm. Someone have some weighting algorithm, other has another one. Okay, which algorithm works better, it depends on their weighting algorithm, how they weight it. Okay, and maybe and also how many times, how many weak learners they combine. Okay, basically this acts, and this whole operation works in a sequential manner. Okay, first learner A, then B, C, like this, and finally we get a non-linear prediction. Okay, So this is the concept behind this boosting algorithm, and and there are some examples of it like ADA boost, gradient boosting, and LGBM. Okay, you can read about these models from your own. You will need this when you will stuck to some stuck that you are not getting better accuracies, and you have no idea how to increase accuracy. Then you can try these models, try boosting algorithm, and you can uh, test that your accuracy increasing or not. Okay, now we have bagging algorithms. Okay, so bagging algorithms works in this way. Okay, first we split the dataset into some subsamples. Okay, and then we train multiple classifiers on these subsamples. We train on this and validate on them. Okay, and in this way, why this is done, here in this bagging algorithm definition we can see that this method is used which used for reducing variance by combining this prediction from multiple classifier trained on different subsamples of same dataset. Okay, so here we are reducing variance. Now recall what I have told about variance. variance Variance is low variance when it is low variance if it's well generalized on different type of data sets. So here what we are doing, we are training on these data sets and validating on these data sets. Okay, so in this way this model predictions have very low variance. It can these parameters are so much generalized that it can perform better in different data sets. Okay, so this is what we do in tagging algorithms. Okay, and we train multiple classifiers, and after that we use voting. Voting is what, like that there's predictions of 0 and 1. This predicted 0 and these three predicted 1. So according to voting, 1 has 3 vote and 0 has 1 vote, so the answer will be 1. Okay, so generally when there is a classification problem, we get it by voting, and when there is a regression problem, we can get all the predictions of all these and then get their average, and we output that. As Ujjwal has already explained in random forest works like this. Okay, so there are multiple different trees here, and their predictions are, if there is classification, we get the output by voting, or if there is regression, then we get the output by averaging. So this is how bagging algorithms work. There are some references of all these methods we have used here. Uh, that's it.
Yeah.
Yeah.
When we are dividing the data samples,
Hmm.
so the it's one data can be present in one data sample only, or it can be presented different.
Yeah, one data set.
Like the data samples are disjoint or not?
I could not get your question. Please explain.
Like if I'm dividing 1, 2, 3, 4, 5 in two
Hmm.
groups, and we are making two groups, 1, 2, 3, and 2, 4, 5.
Hmm.
Then it is right, or we have to divide like 1, 2, 3, and other group is 4, 5.
Yeah, you have to. Yeah, you have to divide it into the second way. 1, 2, 3, and other is 4, 5.
What happens when model variance is high? I didn't understand that.
Yeah, model variance is, see, when model variance is high. Okay, so in that case, it is not well generalized. Okay, so see, you have got some training data. Okay, and your model is, you can say your model is well when you have collected some data. Okay, but it is not given that these data will repeat again and again. There may be some different types of data. Okay, So if your model is well generalized, then only your model can perform better in those. Okay. See, your model should understand the general features, the important features which are common in all these type of data. Okay. They should not learn very specific things about a training data set. So that's why we try to reduce the variance. We got it?
Not exactly, like what is variance of what?
Okay, I will tell you like what is variance. I will tell you basically variance मतलब वो होता है जैसे मान लो तुम्हारा कोई फीचर कोई मॉडल है वो तुम्हारे ट्रेनिंग डेटा पे बहुत अच्छा परफॉर्म कर रहा है, ठीक, बट जो तुम्हारा वो है टेस्टिंग डेटा सेट या कोई नया डेटा सेट आता है तो उस पर उतना अच्छा परफॉर्म नहीं कर पाता, तो उससे हम कहते हैं कि वेरिएंस बहुत ज़्यादा है, मतलब ये अपने जो उसको सिखाया गया उस पर तो अच्छा परफॉर्म कर रहा है पर जब नया डेटा सेट डाल रहे हैं तो उस पर अच्छा परफॉर्म नहीं कर रहा, तो उससे कहते हैं हाई वेरिएंस। तो ये हाई वेरिएंस, और अगर अपने ही डेटा सेट पे अच्छा परफॉर्म नहीं करता है तो उससे कहते हैं हाई बायस। अब समझ में आया?
यस।
ओके
हाँ, तो ये तो ओवर फिटिंग और अंडर फिटिंग वाला का दूसरा नेम हो गया ना।
हाँ, मतलब वही चीज़ है, अगर मॉडल ओवर फिट कर रहा है तो बेसिकली इसका मतलब क्या हुआ, इसका मतलब ही यही हुआ कि अपने मॉडल को जो उसको सिखाया गया या जिस पे वो ट्रेन किया गया वो बहुत अच्छा कर रहा है। ओवर फिटिंग उसको कहते हैं, मतलब वो उसकी फीचर रट लिया एक तरीके से, मतलब उसने ये नहीं देखा कि कोरिलेशन कैसा है, कैसे कैसे फीचर सिमिलर हैं, ऐसा कुछ नहीं देखा, उसने बस रट लिया कि 1 है तो 1 का 2 के साथ मैच हो रहा है, ठीक है, अच्छी बात है। तो बस उसको कहते हैं ओवर फिटिंग, जैसे अपने मॉडल को अपनी ट्रेनिंग डेटा सेट को रट लेना और जब नए फीचर्स हैं तो उसको समझ ना पाना कि इसका आंसर क्या होना चाहिए या ये किस क्लास को बिलोंग कर रहा है, तो उसे ही कहते हैं हाई वेरिएंस या ओवर फिटिंग एक तरीके से, मतलब दोनों को रिलेटेड है, ऐसा कह सकते हो, हाई वेरिएंस ओवर फिटिंग।
हाई वेरिएंस में ऐसी कोई क्वांटिटी है जिसका हम कह सकते हैं कि वेरिएंस हाई हो मैथमेटिकली?
मतलब वो एक अलग चीज़ हो गई, जैसे वेरिएंस मतलब मैथमेटिक वही चीज़ है, मतलब वेरिएंस मतलब ही क्या होता है कि वो मतलब वेरिएंस मतलब ये होता है कि स्प्रेड आउट, मतलब यही होता है। तो बेसिकली वो वेरिएशन, मतलब वो मैथ वाले उस पर मत जाओ, मतलब उसका एकदम मैथ वाले के सेम नहीं है इसका मतलब, जस्ट हाई वेरिएंस मतलब ये होता है कि वो ट्रेनिंग डेटा सेट पे अच्छा परफॉर्म नहीं कर रहा है, ये मतलब हो एक तरीके से, मतलब वो दोनों वेरिएंस में कंफ्यूज मत करो मतलब।
ओके भैया, कोई कंफ्यूजन?
और किसी को कोई डाउट है तो पूछ लो भाई, नहीं तो फिर लीव कर और अगर अक्षत सूद तुम्हें कुछ बताना बता दो भाई।
Just one thing key, we will be releasing another assignment which will be based on the concepts covered in the third workshop, and we will release it latest by 1st Feb. So you may get the assignment before 1st Feb. Yeah, that's all.
बाकी कोई डाउट्स है तो पूछ सकते हो। And one more thing, like try to build, like make your teams of 3, because after 5th workshop we will be releasing a dummy competition. So you need to make a team of 3. No restrictions on how to form a team, but it will contain maximum of 3 people, and so that we will evaluate you both on the dummy competition as well as on the main competition. We will like release the weightage of dummy competition as well in fifth workshop, end of 5th workshop. So try to form teams and try to register for the event as well now, like by forming teams, so that we will be able to like account how much teams will be like actually participating in the event after 5th workshop. And we will like take a note, those who will not be able to like participate in dummy competition, actually they will not be like, they will not have any point in participating in the main competition, because it actually carries a very good weightage of overall event, the dummy competition. So now start to meeting.
सेकेंड असाइनमेंट का सॉल्यूशन कब देंगे?